Hello everyone, today we're going to talk about the measures of central tendency. What is central tendency? Central tendency is the degree of clustering of the data around the center of a distribution. So here's a distribution, here's the center of a distribution, and the measure of central tendency would tell us the degree that the data is centered around here, right? There are three ways of measuring central tendency, and they are the mean, the median, and the mode, and we're going to talk about each of those. First, we're going to discuss the mean, which is also called the average. So this is something that you've probably done several times. It's just now has a slightly different name. It's the average of all the scores in a data set. It can be symbolized by X bar, which is this right here, or M for a sample, and mu right here for a population. Now, mu looks kind of like a U with a tail in the front. Here's the equation to find the mean. It's basically the sum of all the scores divided by the number of scores. So n represents the number of scores. So if I were to ask you what in this data set, what is x1, you would say 0. I would say what is x4, you would say 95. So these are all x scores. So you sum all of those and then divide by the number of scores. So when we sum these, we get 274, and the number of numbers here is 4 numbers. So when we divide that, we get that the mean of this data set is 68.5. Now the good thing about the mean is that it accounts for each and every score in a distribution. So all of the scores are used in the calculation. The problem is that the mean is affected by extreme scores or outliers. So in our example, let's say we use test scores. Look, there's the top 3 scores of 87, 92, 95. If we compare those with the mean, these are much higher, and 0 is actually much lower. What if we remove the 0? Because let's say that person just never showed up for the exam. Is it really fair to use that score in saying the average test score was, 68.5, which is, a D+. When we remove the outlier, so we take away the 0, we get a 91.33, so the exam actually seems much easier now that we look at it this way. If we were to leave that 0 in, people might think, oh my gosh, that's awful, the D+, that's an awful average for an exam. But when we actually remove the outlier or the score that probably shouldn't have been counted, we get, 91%, so that kind of signifies an easier exam. Now, how does the mean change when we add scores to the data set? If we were to add a score below the mean of 68.5, so in this case we added 36, then the mean decreases. So it's pulling the mean in that direction. Now, if we were to add a score above the mean of 68.5, the mean increases because it's pulling the mean in that direction. Now, what do you think would happen if we added the mean? Would it change? If we added the mean, it would not change the mean at all because it's not pulling one way or the other. The mean is used more than the other two, the median and the mode, because it can be calculated and used algebraically, so I'm spending more time talking about the mean. It is typically stable from sample to sample, so if you were doing a study and you took one sample of people and got the mean for that, and then you took another sample of people and got the mean, and another sample and got the mean, and so on, then those means would typically be stable, right? It would be similar means across all the different samples. You can only use it with interval and ratio data. For example, if you listed your favorite breeds of dog, which is a nominal variable, it would not make sense if I asked you to give me the mean of that list, right? Here's a bull pug, right? A pug is one of my favorite breeds of dog. And I also like bulldogs, although I don't have a bulldog. But if we were to add these together, what do we get? A bull pug, which is the picture shown right here. That doesn't really make sense, right? Adding those together. Bull bug divided by 2, that doesn't make sense either. So nominal variables, you can't really be adding them, and you can't divide it. It doesn't make sense to get a mean. Now the median is the middle score. This equation, the sum of n plus 1 divided by 2, tells you the location of the median. So it tells you which term it is. So we have this data set right here. And there are 5 numbers, so we take 5 plus 1, which is 6, divide that by 2, and we get that the median is the third number in the set, which in this case is 87. But what if there's an even number of numbers in the set? Well, here we took away 36, so we only have the 4 original scores now, and we get 2.5. So which term is that? Well, there's not a term in the middle, so we have to kind of create one. So you take the average of the two, it would be the second and the third terms, right, to get the median. And in this case, you took 87 plus 92 divided by 2, and you get 89.5. So although this number isn't directly in the data set, it is the number directly in the middle. So we would use that as the median. And here is just a real-life visual of a median that might help you remember what the median means. There are several roads with the cement and grass median that divides the road. So it's dividing the road in half, right? So there's road over here and there's road over here. So if you have trouble remembering what the median is, think of your daily life in that example of the median in the street, and that should help you remember that the median is just in the middle. The median is also called the 50th percentile, and it is relatively unaffected by extreme scores. Now, how does that change when we add scores to the median? Okay, let's say we added a score below the median here. So we added 83. When you divide that by 2, we get 85. And that shows that it's slightly decreased, but not very much. Now if we add a score above the median of 87, so we added 10,000 over here. So we added a huge outlier. We're obviously not talking about test scores anymore. But if we added that, it doesn't really change. I mean, you would just move up 1 unit. So we would get 89.5 as our median, but it didn't really change that much. Now, what if you add the median? In this case, we added 87. We get, the median is still 87. It didn't change. Now, when is the median useful? You can use the median with sometimes ordinal data, interval data, and ratio data. So when there are outliers or extreme values that affect the mean, the median is a really good measure of central tendency. For example, in the last slide, we had this data set, right, with this huge outlier over here. We had the median of 85. Because take out this outlier, it better represents the scores, right? So we're not really needing to include that 10,000, but if we were to include the 10,000, which is what the mean would do, it would say the average of these scores was 1,725. And if you look at them, that doesn't make any sense for these scores over here. It's not even close. I mean, obviously this score is much larger than this, so it doesn't represent that very well either. But if we, most of the time they would just delete the outlier and take the average of the rest. Now, do you see how using the mean in this case might be a huge issue? So one way to deal with that, like I said, is to throw out extreme outliers, to use the mean to be able to calculate it algebraically. Now, housing prices are reported using the median. Why do you think that is? Well, all we have to do is think of Bill Gates. His home is, the most extravagant. Oprah, she obviously has extravagant homes. So these are outliers. So Bill Gates and Oprah, their home prices would be extremely high, and it would pull that mean up and make it look like the housing prices, the average house price would be a lot more expensive than it actually is. But if you use the median, which is how housing prices are reported, just uses the middle. So it's a better measure there, and it kind of gives people better information than using the mean. Now the mode is the score that occurs most often. Now what is the mode in our original data set? Right? We have 0, 87, 92, 95. There's no mode because nothing occurs most often. However, if we have this nice long data set that I wrote, what is the mode? Well, 36 is the most frequent number in the set, so is the mode. It doesn't tell us much, is most useful with nominal data. An issue is that it can take on several values. We can have bimodal distributions where there are 2 modes, or even multimodal distributions where there are more than 2 modes. At some point, though, it doesn't become useful at all because there are so many numbers that occur at the same rate, right? Now here are some distributions written out. We have a negatively skewed, and that you can tell by the tail being on the negative end, and a positively skewed, the tail, that's how I always remember it, the tail is on the positive end, so it's positively skewed. You can see how the mean, median, and mode kind of lie on these distributions. On a normal distribution where there's no skew at all, these numbers are all equal, right? This is perfectly symmetrical. Everything's balanced. But when you move things around, like this is a negatively skewed, so the mode is here, the median is here, the mean is pulled down by these outliers. And in this case, the mode being here, which is, if you can tell, all these cases, the mode is the highest frequency. The mean is pulled down over here by these outliers, or pulled up over here by these outliers, because there's outliers that are really high. So the mode is being, or the mean is being pulled up by these outliers. Now let's use the mean, median, and mode in this data set. We're going to use the same data set to find all of them. So if we find the mean, we add up all the scores. There are 12 scores. We divide by 12, and we get a mean of 54.5. The median, we take the average of the 6th and 7th term to find that. And the 6th and 7th term happen to be both 56, so the median is 56. And finally, the mode. There's 3 56s in the data set, and that's the most frequent because everything else only occurs once. So the mode is 56. So these are actually pretty close. All 3 of these are pretty close to one another in that case. Now you want to use SPSS to find the mean, median, and mode. So I have put together a little kind of tutorial that we can put on video here using pictures. So you pull up SPSS, and the first thing you want to do is go to variable view. Now I just put in anxiety score because we're going to use this last data set that we just calculated by hand. So you put anxiety score in for the name of the variable, or whatever you want to name your variable. Now SPSS won't allow you to use spaces, so I get by with using underscores because I don't like to just cram all the words together, so I use underscores. Now the next step here would be to go to data view, so these 2 tabs at the bottom. Go to data view, and you have your anxiety score listed up here, right? So then you would list all the scores that we had. So we had 30, 34, 35, 45, 3 56s, a 58, 59, 62, 63, and 100. So we had, like I said, 12 people. Now the next step would be to go to Analyze, Descriptive Statistics, and Frequencies. And when you do, this little box will pop up. And the first thing you have to do is move your anxiety score over using this arrow to the variable box. It will look like this. And then when you're done there, you want to click this button, Statistics. Now, once you do, this pops up. And here you can see that I've already checked mean, median, and mode, and that's what we want, mean, median, and mode. So you check those three things, and then you click continue, and when you do, this box will pop up. And you just click OK. And you'll end up with a little box of information, the descriptive statistics that tell you the mean, which we calculated at 54.5, and so did they. The median was 56, and the mode was 56, so we were correct. And all of our stuff matches what SPSS gives us. So you can see here that N is 12, so there should be 12 people in our study basically that we checked their anxiety scores. Now, in summary, the mean is the average, and it is affected by extreme scores. However, it can be manipulated algebraically, and it takes every score into account. The median is a middle score, or the 50th percentile. It is useful when there are outliers, but it does not take every score into account. And finally, the mode is the most frequently occurring score. It is the most useful with nominal data.